Soil is the most commonly used construction material. From glass to brick to Portland cement concrete and asphaltic concrete, soil in its different forms is a component of all of them. Soil, a complex mix of mineral fragments, organic material, moisture, and gases, provides us with food, lumber, and medicine. It contains our groundwater, provides support and construction materials for our buildings, roads, airports, and has many other uses, countless in number. DOTD requires the use of soils for purposes such as backfilling excavations around pipe or other structures, providing embankment to support pavement structures, building base course for a road, railway, or airfield runway. Some soil, in its raw state, will not be suitable to use for construction purposes. To make a soil mass stronger and better able to support traffic loads, we compact the soil during the construction process to make it more dense. Then we perform tests to measure the in-place density of the soil to determine if it meets the minimum density required by the department's specifications. To expedite the construction process and assure that the material used is of the best quality, DOTD wants test methods that are timely, accurate, and easy to use. For in-place density testing of soils, the nuclear method meets these criteria. That is why it has been designated as the department's standard test for in-place density. This video will discuss the use of the nuclear method to test for in-place density. In-place density is the actual density the contractor achieves on the roadway. This video has been produced to give the inspector technician more in-depth training in how to use the nuclear method. The nuclear method uses a portable gauge called a nuclear device. This device is specifically designed to measure the density and moisture content of soils. The nuclear device uses radiation to obtain wet density and moisture readings of the in-place or compacted material. These readings are then processed by the device to acquire a value for dry density of in-place material, which is used to find percent density. Because the nuclear device used for the test contains radioactive components, numerous precautions must be taken to meet all state and federal regulations pertaining to the use of radioactivity. Only an authorized nuclear device operator can operate a nuclear device and therefore perform the testing procedure. Operators are licensed under the Materials Engineer Administrator, who is the licensing authority for the department. To become an authorized nuclear device operator, you must successfully complete all training, which will allow you to possess a valid thermoluminescent dosimeter or TLD badge, and an operator's license issued by the Materials and Testing Section. Only those meeting these requirements will be allowed to perform testing with a nuclear device. The testing procedure used for the nuclear method is DOTD TR401, the determination of in-place density. When using a nuclear device to conduct in-place density tests, the testing method corresponding to the device model number must be used. This video will discuss Method A of this test procedure, which covers the Troxler Model 3440 nuclear device. We will go through the test procedure step by step, but first, we will discuss a few safety precautions you must take whenever you are operating, transporting, or working near a nuclear device. If you use this equipment as instructed in your training manuals and the operator's manual, there is no danger of overexposure to radiation. However, improper handling, transport, or operation may lead to radiation hazards. The TLD badge, which registers exposure to radiation, is to be worn at all times when transporting, handling, or operating a nuclear device. Also, the operator's license is to be carried at all times when you are transporting, handling, or operating a nuclear device. Never allow anyone else to wear your badge or use your license. Anyone handling or operating a nuclear device must have his own badge and license. If you have any kind of problem with your nuclear device, for example, it won't operate, it's operating incorrectly, or the device is damaged or stolen, contact your supervisor immediately. Don't try to fix the device yourself. Your supervisor will know whom to call when there's a problem. The nuclear device. Let's take a moment to become familiar with the features and controls of the nuclear device. This is the nuclear device. It contains the radioactive sources, electronics, and the rechargeable battery packs. This is the keypad or control panel. This particular device has 22 keys, 20 in the control section and the on-off keys. When you press a key, an immediate beep should be heard. If not, then the key press did not take. We will talk about various keys as we go along. This is the index rod. Notice that it is notched. The rod next to it is the source rod. The notches on the index rod are used to hold the source rod in place when you're moving it into different positions. There is a trigger on the handle of the index rod, which, when squeezed, allows you to move the source rod up and down through different operating positions. The trigger must always be in the safe position when the device is not in use and locked when the device is stored and transported. This is the transport and storage case for the nuclear device. It is specially fitted to safely transport and store the nuclear device. It is not watertight, nor does it provide radiation shielding. It must be equipped with the proper locks and must be kept locked at all times when the nuclear device is inside. When the nuclear device is not in use, it must be kept in this case. This is the reference standard block. It is primarily used to establish standard counts. Each nuclear device has its own reference standard block. The blocks are not interchangeable between machines. This is the scraper plate drill rod guide. It is used to prepare the test site and aid in guiding the drill rod to prepare the source. This is the drill rod. It is used to drill a hole for taking measurements. The source rod on the machine should never be used for this purpose. The drill rod extraction tool provides leverage to remove the drill rod from the soil. This is the standard count log. This log is used to record standard counts for the device. Other equipment you will need includes dry fine sand and hand tools such as a 1.8 to 2.7 kilogram, 4 to 6 pound hammer, a shovel, and a straight edge. All test results will be recorded on the density and moisture content worksheet, shown here. Prior to taking measurements, you should determine the unit of measurement you want for screen displays or printouts. The device allows you to choose between metric or English units, kilograms per cubic meter, or pounds per cubic foot. To execute the Set Units function, press Shift and Special. Follow the display instructions to get the required units. The device will remain in that mode until it is reset. Standardization. Once you arrive at the test site, the first thing you will do is take a standard count. A standard count is basically a calibration procedure used to ensure that the machine is working properly and the test results you acquire are valid. This count is compared with actual field results in order to cancel any drift or error in the equipment. Standard counts are done for moisture and density. You take a standard count once each day when the device has been idle for 4 hours and when you suspect that the test results may be wrong. Once you have a correct standard count, you don't have to repeat the procedure if you test in another area. As long as conditions are similar and the machine has not been idle for 4 hours, test results are valid. You'll need the device and the reference standard block for this part of the test. The standard count should be taken near the site where the actual test will be taken. Turn the device on by pressing the On key. The device will automatically go through a self-test routine for 5 minutes. Don't turn the device off while the self-test display is on. Interrupting the self-test may cause the device to lose memory. Clean the top of the reference standard block. Keeping the source rod retracted inside the machine, clean the base of the device. You want to make sure there is no soil or other material to prevent a good seat between the device and the block. Air gaps between the device and the block will make the test results invalid. Place the reference standard block on the compacted material that has a minimum density of 1,602 kilograms per cubic meter, or 100 pounds per cubic foot, that is at least 1.8 meters or 6 feet from any large object, including vehicles, and at least 9 meters or 30 feet from any other nuclear device. The operator should stand away from the device when taking the standard count. When a test is to be performed in an area with less than 1.8 meters or 6 feet of clearance from a close vertical structure, the trench offset factor will come into play. We will discuss this in a minute. Place the nuclear device on the reference standard block with the source rod in the safe position, making sure there is a good seat between the device and the block. The device must be positioned between the raised edges of the block and with the side of the device firmly seated against the metal butt plate on the block. Press the standard key to obtain the first display. The display will show the standard counts and a question similar to this. Press the Yes key to take a new count and obtain the second display. If the device is on the standard block and the source rod is in the safe position, press the Yes key. A third display will appear. At this time, the nuclear device will begin to take a 4-minute standard count. When the standard count is completed, the device will beep and display the results of the standard count. The device automatically compares the new standard count to the average of the last 4 standard counts. The new standard count will pass if it is not more or less than 1% of the density average or 2% of the moisture average of the last 4 counts. If the count passes, there will be a P for pass to the right of the percentage figures on the display. If the percentages are not within these limits, an F will be displayed. If an F, which stands for fail, is obtained, you'll have to correct the problem if you can. Take a look around. Are there any other nuclear devices nearby? Is the device seated correctly on the reference block? Are the device base and reference block top both clean? Is the reference block on a recommended surface? Is the reference block the correct one for that particular device? If all other conditions are normal, don't accept the standard count just taken. Press No and take another standard count, regardless of whether or not the cause of the failing percentage was identified. If, after having taken 3 additional standard counts, an F still appears in the display, contact your supervisor, who will contact the district laboratory engineer before sending the device to the materials and testing section for evaluation. When the display indicates that the density standard counts are within passing limits, record the values displayed on the device on the worksheet. These counts must also be recorded on the standard count log available with each device. Press the Yes key to accept the new standard counts and store them in the memory of the nuclear device. These standard counts will remain in the nuclear device's memory and will be used for the calculation of data until a new set of standard counts is obtained and stored. Trench offset factor. As a result of radiation echoing from close vertical structures, the walls of a building, trench, or ditch may adversely affect density and moisture counts. As we mentioned previously, when a test is to be performed in an area with less than 1.8 meters or 6 feet of clearance from close vertical structures, the trench offset factor must be used to obtain an accurate reading. In order for the trench offset factor to be determined, a measurement count using the reference block must be taken after the standard count is taken. Arrange the reference standard block in the same way as described earlier, except that the reference standard block will be set at the exact location to be used for the density test. Press the Offset key to obtain the first display. The display will show the offset selections. Press the 3 key to select the trench offset. Press the Yes key to obtain the following display. Press the Yes key again to obtain the following display. Press the Start key to begin a 1-minute count. After counting down to 0, the display will show the following. Press the Yes key. The device will return to the Ready mode. The trench offset factor procedure must be done for each new test location where the factor is required. Once enabled, the trench offset factor is retained in memory and will affect all future test results until the device is turned off or the function is disabled from the device keypad. Therefore, the trench offset must be disabled prior to performing the next test. Disable the trench offset factor by following the previously mentioned steps, but when the device asks if you want to use the trench offset, press No. The density testing procedure. Site location. Select a test location greater than 1.8 meters or 6 feet from any object that may interfere with the testing process and cause erroneous results. Some examples of things that can cause erroneous test results are a trench wall, ditch, or adjacent structure, cars, trucks, or construction equipment near the testing site, a large body of water or high water table near the site, or too many people gathered around the device when it is working may affect moisture counts. Always be aware of your surroundings when you're about to perform a test. Select the test site randomly in accordance with the material sampling manual or as directed by the engineer. Testing. Set the nuclear device to obtain a 1-minute test count. The time for which the nuclear device is set will be displayed when it is in the ready mode. If the nuclear device does not indicate a 1-minute count, press Time on the keypad for this display. Press the number of minutes, in this case 1, you want for the test count time. The display will return to Ready. Enter the maximum dry density, obtained from a Proctor test or a moisture density curve, into the nuclear device by pressing the Proctor-Marshall key. The display will show the last maximum dry densities entered and a question. Press the Yes key to make a change in the entry marked PR. The display will ask which one to change. Select 2 for PR and press Enter if required. The display will read, Enter the maximum dry density by pressing each number and decimal point in sequence on the keypad. Each number and the decimal point will be displayed as it is pressed. The display will show the maximum dry density as shown here. Record the maximum dry density on the worksheet. Store the maximum dry density in the device memory by pressing the Enter key. This maximum dry density will be used to determine the percent density until a new maximum dry density is stored in memory. Next, it's time to prepare the test site. Place the scraper plate on the surface to be tested and move the plate back and forth in a small area to smooth the test site. Lift the plate to remove all loose stones or surface materials and fill small voids with sand or fine material from areas near the test site. Place the scraper plate on the surface again and press down slightly to level the surface. Seat the device solidly on the prepared site with the probe at the location of the intended access hole to check the surface to see if it is prepared correctly and level. Identify and set the test depth to be used. The test depth must be the deepest setting possible that will not penetrate beneath the lift of the material being tested. For example, the source rod can be set in 1-inch settings. If you have an 8.5-inch base course, you would set the rod at 8 inches. Using the scraper plate drill rod guide, the drill rod, and the hammer, place the scraper plate at the location you have just prepared. Put the drill rod through the extraction tool and then through one of the guides on the plate. Put 1 foot on the plate to hold it firmly and hammer the drill rod at least 50 millimeters or 2 inches deeper than the test depth to be used. Before removing the drill rod from the scraper plate, mark the test area to make it easier to place the device over the site. Remove the drill rod by pulling straight up in order to keep the access hole intact. Use the extraction tool if necessary. Don't loosen the drill rod by tapping from side to side with the hammer. The probe hole must be perpendicular to the surface. Otherwise, as the device is rotated, the source rod will lose contact, causing test error. Place the nuclear device on the prepared area. Insert the source rod into the access hole using the handle and the trigger mechanism to the predetermined test depth. Release the trigger at the desired depth and listen for the positive click, indicating that the source rod is properly locked into position on the index rod. Press the top of the handle lightly to confirm positive source rod locking. Seat the nuclear device solidly by rotating it about the source rod using a back and forth rotational motion as demonstrated here. Be sure that the entire bottom of the device is in complete contact with the prepared surface of the material to be tested. The right side of the source rod must be firmly in contact with the side of the hole. After the device is seated, if there are still voids between the bottom of the nuclear device and the prepared surface to be tested, fill these minor depressions with sand or fine material from around the test site and reseat the nuclear device. Just fill in any holes. Don't build up the area where the nuclear device is to be in contact with the surface. If this is not possible, additional preparation will be necessary. Press Start Enter on the keypad to begin the test counts and step at least 3 feet away from the machine. After the 60-second count period, the device will display readings for wet density, moisture, dry density, percent density, and percent moisture, as shown here. Remember, test counts for density and moisture represent the material at the time of test. Wet density is the only accurate reading you're getting from the device. You need wet density and moisture content to calculate dry density. The nuclear device takes wet density and moisture readings to calculate dry density for you. However, moisture contents from the nuclear device are not considered to be very accurate. You must get a moisture content using the stove or oven drying method. Use your results from the stove or oven drying method with the device's wet density to calculate dry density. It will be necessary to perform moisture correction procedures on some materials because they contain hydrogen in a form other than water. These materials are soils or soil aggregate mixtures, which contain reclaimed asphaltic concrete, recycled Portland cement concrete, lime, fly ash, coal, mica-bearing clays, gypsum or calcium sulfates, phosphates, or organic matter. Boron and cadmium will also cause erroneous nuclear moisture readings. Soils or soil aggregate mixtures containing these materials will require the determination of their actual moisture content with the stove or oven drying method. Record all test results on the density and moisture content worksheet. Obtain the density count by depressing the Shift key and the Counts key. The Shift key and the Shift function keys must be used to obtain the density count. Shift and Shift function keys are yellow. The Shift key must be pressed before pressing a function key. Pressing the Shift key causes the display's top line to change to Shift function. After the Shift key is pressed, you have 4 seconds to press the proper function key, or the device will react as if no key had been pressed. Record the density count for test 1 on the worksheet. Repeat the testing sequence for 2 more tests. The 3 tests must be taken at intervals of approximately 120 degrees around the same access hole. Record the results from all 3 tests on the worksheet. If the dry density of any test is more than 48 kilograms per cubic meter, or 3 pounds per cubic feet below the highest dry density of the 3 tests, reseat the nuclear device in the same orientation as the original test and rerun the test to verify the results. Use the higher of the 2 test results, original and retest, to calculate percent density. Use the moisture from the stove or oven drying methods. If the moisture from the nuclear device is within plus or minus 0.5% of the stove or oven drying moisture, you can use it to calculate dry density and percent density. Record retest results on additional forms. When a test is taken within 1.8 meters or 6 feet of a vertical surface, pipe, structure, etc., using the trench offset factor, only 1 test will be required. Average the values of the 3 tests and record on the worksheet. To recall the last test taken, press Shift, then press the Recall key. The display will show the results of the last test taken. Using the maximum dry density figures from the Proctor test or the moisture density curve, do calculations to obtain percent density for the material. If you encounter any problem, are in doubt about a situation that arises, or if the device is lost, stolen, or damaged, notify your supervisor immediately. Remember, if used correctly, The nuclear device is a safe and effective means of obtaining in-place density for an embankment and base course. Thanks for watching.